Alright, today we're going to learn about solving projectile motion problems involving angles. To do this, let's look at this sample problem. There's 4 parts to this problem. An athlete kicks a soccer ball with a velocity of 18.1 meters per second at a 28-degree angle from the ground. Find the horizontal component of the starting velocity. Find the vertical component of the starting velocity. How much time will the ball be in the air before it hits the ground? Find how far the ball travels horizontally before hitting the ground. So the first part of the problem is finding the horizontal component and the vertical component of this starting velocity. To do this, we are going to draw a triangle. This represents our starting velocity, which was 18.1 meters per second. And that was at a 28-degree angle. So to complete this, we draw our triangle with a horizontal component and a vertical component. We label them Vx for the horizontal and Vy for the vertical. Now that we have Vx and Vy, we simply remember to use our sine and cosine to figure out the magnitude of Vx and Vy. So the cosine of 28 degrees equals adjacent over hypotenuse. So that'll be Vx over 18.1. So to solve for Vx, I multiplied both sides by 18.1. 18.1 times the cosine of 28 degrees. That will equal Vx. And so I push a few buttons on my calculator, making sure I'm in degree mode. That's an important part. So 18.1 times the cosine of 28 degrees is 15.98. So we'll just call that 16. So 16 meters per second is Vx. So that's our horizontal component right there. To find our vertical component Vy, we're going to use the sine. So the sine of 28 degrees equals opposite over hypotenuse, Vy over 18.1. So I multiply both sides by 18.1. 18.1 times the sine of 28 degrees equals Vy. So again, I get to my calculator, I push some buttons, 18.1 times the sine of 28 degrees, and I get 8.497. We'll call that 8.5. So 8.5 meters per second is Vy. Alright, so now that we found Vx and Vy, we're ready to move on to the next part of the problem, which is how much time will the ball be in the air before it hits the ground? To do this, we need to split our problem into a horizontal part and a vertical part. So we just write horizontal, and we write vertical, and we're going to fill in our information. We remember that horizontally we have constant velocity. So there's d, v, and t. Vertically we have acceleration, so we're going to use all 5 of our variables, v naught, v, a, d, and t. And now we can fill in things that we know. We remember that the horizontal velocity was 16, and because it's constant velocity, that's going to stay the same the entire time. So Vx, because it's 16, when we come back here, we know that our horizontal constant velocity is 16 meters per second. Our vertical starting velocity is the vertical component of that starting velocity, the 8.5, the Vy. That's the vertical component of the starting velocity, so that is our vertical starting velocity. So Vy, which was 8.5 meters per second. And the direction is important here. This initial velocity was up because the soccer ball was kicked at an upward angle. So I'm put a little arrow here to indicate that it was up. We also know vertically the acceleration is 10 meters per second. It's the acceleration due to gravity, meters per second squared, and it is in the downward direction. Now, it seems like that's all we know, but let's go back to the original problem, and it said, how much time will the ball be in the air before it hits the ground? Now, the ball was kicked from the ground, and it returns to the ground, which means that vertically, the displacement will be 0. It ends up at the same vertical height from which it was kicked, therefore the vertical displacement is 0. So to find how much time it's going to spend in the air, it looks like vertical is the way to go here. So we're looking for time, which means we don't need v. Don't need v, we use our don't need v equation. d equals v naught t plus 1/2 a t squared. And now, because we have a starting velocity that's up and an acceleration that is down, we need to make one of those directions negative. So we're going to make sure that down is negative, but we'll negative 10 there. So now we just fill in our numbers. 0 equals 8.5 t plus 1/2 times negative 10 t squared. So at this point, 0 equals 8.5 t. Half of negative 10 is minus 5 t squared. So now this is one of those interesting cases where I have a t and a t squared. So I could use a quadratic formula or graph this, but because the displacement is 0, there's actually an easier way. We can divide everything by t, and when we take 0 divided by t, we get 0. 8.5 t divided by t gives us 8.5, and then minus 5t squared divided by t gives us minus 5t. So 0 equals 8.5 minus 5t. So let's start with that. 0 equals 8.5 minus 5t. So to solve this for t, we simply add the negative 5t to both sides. So 5t equals 8.5. Oh yeah, that's positive because we're adding it to both sides. So t will equal 8.5 divided by 5. And here's where we simply push a few buttons on our calculator again. 8.5 divided by 5 is 1.7. So the time is 1.7 seconds. So now we know how much time the ball is going to spend in the air. And we're ready to move on to the last part, which is find how far the ball travels horizontally before hitting the ground. So remember, on our horizontal information, we knew that the velocity was 16 meters per second. We just found vertically that the time is 1.7 seconds, and so we're ready now to find our horizontal displacement. We use our equation for constant velocity, d equals vt, and so that's going to equal 16 times 1.7, and we push our buttons on the calculator here, 16 times 1.7, and that gives us a displacement of 27.2 meters. And that is how you solve a projectile motion problem involving angles. I hope you've enjoyed this and learned what you needed to learn from it. Thanks. Have a great day.